Okay, now we're going to talk about the triangle proportionality theorems, and later on in the notes after this you're going to see we'll go a little bit more in depth, and there'll be a couple of practice problems for you to go over, but right now we need to put this together. This is a little confusing on how we want to put this together, so let me show you. The first thing you want to do is flip this page over, so we have triangle proportionality theorem followed by the converse of the triangle proportionality theorem. And then of course we want to make sure we have our title on the back. So you should have triangle proportionality theorem, converse of the triangle proportionality theorem, then triangle mid-segments theorem. So then we're just going to fold it down, match up with that line there. And then we'll just fold and staple it, and then we will fill it out. Okay, now that we have our triangle proportionality theorems all put together, let's go ahead and fill it out. So our first theorem we're going to start with is the proportional segments theorem. The proportional segments theorem states if three parallel lines intersect two transversals, then they divide the transversals proportionally. So I've kind of drawn a picture over here. So you can see I've got my three parallel lines and I've got my two transversals. And what happens is we get a proportion. A over B equals C over D. So that's this right here. And then up here I've done a practice problem for us. Let me pull that down so you can see. So how we would set this up, we would look down here. This is kind of like our little key, and we would just set it up the same way. So we have 12 over x equals 16 over 4, and you can see that right here. Then we're going to cross multiply. When I cross multiply, I get 16 times x equals 12 times 4, and then I go through and I just do the algebra. 16x equals 48. X is going to equal 3. Our next theorem is the angle bisector proportional side theorem. And that one states a bisector of an angle in a triangle divides the opposite side into two segments whose lengths are in the same ratio as the lengths of the sides adjacent to the angle. That's a lot of words. Let's look at this picture. First things first, do you remember what an angle bisector is? An angle bisector, it cuts this angle right here in half. So you can see my two angles are marked as congruent because they're half of the whole angle. All that happens is when we have an angle bisector, I can take this side right here over this part of the third side, and that's going to equal this side over here over this part of the third side. So A over B equals C over D. Now my practice problem, I flipped it upside down just to kind of give you some variety. They're not all going to look like this. Same concept though. We have 10 over x equals 5 over 4, and then you can see I've just done the cross multiply and divide out. We get x equals 8. Our next theorem is the triangle proportionality theorem. The triangle proportionality theorem states that if a line is parallel to one side of a triangle, it intersects the other two sides, then it divides the two sides proportionally. So these two sides are parallel. I've got a line in the middle of my triangle somewhere, and it's parallel to this third side. Well, this is kind of like the first one that we talked about here, the proportional segments theorem. It's the same thing, only here we didn't have the whole triangle. If these lines kept going and intersected, we would have the whole triangle. So that kind of makes sense. So A over B, again, equals C over D, but only if these are parallel. So here's a practice problem up here. You can see. So we have 6 over 2 equals 9 over x. We do out the math. We get x equals 3. Our next theorem is the converse of the triangle proportionality theorem. So our triangle proportionality theorem says if these are parallel, then they're proportional. The converse, if you remember, converse are the flips. So we're just flipping the hypotenuse and the conclusion of our sentence. So if the sides are proportional, then that means these lines have to be parallel. So it works both ways. So if a line divides two sides of a triangle proportionally, then it is parallel to the third side. And our last theorem is the triangle midsegment theorem. And this one trips a lot of students up. I'm not really sure why. It's just one of those that a lot of students seem to have issues with. It states that the midsegment of a triangle is parallel to the third side and is half the measure of the third side of the triangle. So, midsegment, the triangle midsegment, what we do is we measure each side or two sides of the triangle and we find the midpoint. So here, this side is 6 centimeters. So my midpoint's going to be right here, and I'm going to have a 3 centimeter piece and a 3 centimeter piece. On this side right here, it's 8 centimeters. So I have 4 centimeters and 4 centimeters. And I have my little marks on here as well to show you. These two are congruent and these two are congruent. And then if I connect them, that means it's going to be parallel to the third side of my triangle. It just happens. It's just one of those things that happens every time that we do this. And then it's also, the midsegment is going to be half of this third side. So whatever this third side is, the midsegment will be half of it. And for some reason that just confuses students. So I've got this practice problem up here. These are really easy. We just find this third side and we take half of it. Or we find this and we double it to get this. And also these are congruent. That is what gets a lot of students. So if you see the little marks, the congruency marks, remember congruency marks. If they're marked the same, they're the same measurement.